Here's some very basic simplified square root problems. It's a good skill refresher for when we do quadratic formula, or if you have to solve quadratics and you have to plus or minus the square to get the answer. So we'll start with a really basic, maybe like square root of 16. No, square root of 16 is 4. 16 is a perfect square. 4 times 4 gives you 16, so when you square root 16, you get 4. Square root of 8, not so much. 8 is not a perfect square, so the way that you attack those are try to take that number 8 that's underneath and see if you can't factor it into two, like the product of two numbers to which one of those two numbers, they're called factor pairs, one of those two factors are a perfect square. So 8 will actually break apart into 4 times 2. And there's a square root property when you have multiplication that says if you multiply a product under the square root, you can also do the square root of the product. So we can break that apart into square root of 4 times square root of 2. We can evaluate the square root of 4, which is exactly 2, and that gets multiplied by the square root of 2. So square root of 8 is equivalent to 2 times the square root of 2. It's just in simplified radical form. All right, here's another one. Say you did square root of 90. Okay, you can all the factor pairs that give you 90, you know, like 1 times 90 or 2 times 45 or 5 times 18. But it will only be helpful to you if one of those products includes a perfectly squared number. So like for 90, you can take 90 and split it into 9 times 10. When you do so, you can split apart the square root of 9 times the square root of 10. You evaluate the square root of 9 to be 3, and that gets multiplied by the square root of 10. You know, 10, while it's not a prime number, it will only break apart and as a product of like 1 times 10 or 2 times 5. So 10 doesn't have any more perfect square factors in it, so that means you're done simplifying the square root of 90 to be 3 square root of 10. Take square root of 80, for example. You know, you have 80, you can do 1 times 80, you can do 2 times 40, you can do 8 times 10, but you need to figure out what would 80 divide by. You know, 80 divided by some number, if that would be a nice even whole number where that number was a perfect square, then that would help you break apart 80 to do a product. So, you know, 80 will divide by 4. If you do 80 divided by 4, you get 20. So sure, if you want to try that route. 4 times 20 is 80. If you want to break those apart, square root of 4, square root of 20, that a value, you know, simplifies to 2 times the square root of 20. And then you have to consider that square root of 20. Is it simplified? Am I done? And for this one, no, you're not done, because 20 will break apart even farther. So you, instead of 20, you could write square root of 4 times 5. And then what you'd have to do is break those apart one more time, evaluate that additional square root of 4 to be 2, and multiply it with the 2 that was already out there. So you actually get 4 times the square root of 5. So what could have happened for the square root of 80? I mean, you can go this route. You just have to acknowledge whether or not that number that was left under the radical, am I done? Is it simplified? Can I take it farther? Okay, if you can, like we did above here with the 3 square root of 10, you know, go for it. Otherwise, you have to take it to all the way simplified form. Had you taken the square root of 80 to begin with, if you had taken the square root of 80 to begin with and thought, okay, all the things, sure, 84, that'll go 20 times, but maybe I can divide 80 by something larger, that's a perfect square. So if you take 80, I mean, you can run through your calculator, take 80 and divide it by 4, 80 divided by 9, 80 divided by 16, 80 divided by 25, 80 divided by any sort of perfectly squared number, and you'll get that you can break 80 apart into 5 and 16. So 16 being a larger perfect square than we did before. So square root of 80 could be broken apart as the square root of 16 times 5. Split those up, square root of 16, square root of 5. Evaluate that square root of 16 to be 4, multiplied by the square root of 5, and that gets you, it's the same answer as the previous slide, but it gets you there quicker because the division happened with a larger perfect squared factor to get us to our end result. So the degree of difficulty with these is really dependent upon how large that number is. You know, say for example, it was the square root of, let's see, 396. Okay, well, 396, that's great. You can do some kind of tricks. It's even, it's 2 and something, but take the 396 and see if it'll divide, you know, will it divide by 4? Will it divide by 9? Will it divide by 25? Again, it's, you know, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared. See if it will divide by any perfectly squared factors. And you'll find for 396, 396 will divide by 36. It's actually 36 times 11, 36 being a perfect square. So if we break those apart, we get square root of 36 times square root of 11. Square root of 36 is just 6. Square root of 11 we leave. 11 is a prime number, has no other factors besides 11 and 1. So we cannot simplify the square root of 11 any farther. And 6 square root of 11 is your final answer for that radical simplification. All right. And when you're thinking about taking those square roots and doing the division, you know, don't stop with single digits. I mean, you may have something like, let's see, let's do the square root of 1,183. Now, that's a larger number to have to do the square root for. But if you take 1,183 and start dividing it by 4, divide it by 9, divide it by all of those things, then you'll find that 1,183 will actually divide by 13. It'll also divide by 8, but 8's not a perfect square. It'll divide by 13, you know, so don't stop at like 1183 divided by 9, 1183 divided by 16. It will divide by, if you square 11, you get 121, and that's what this ends up being. Not 11, sorry, 1183. If you start dividing it by all those perfect squares, don't forget that like 9 squared is 81, 10 squared is 100, 11 squared is 121. You know, go to those larger ones because you'll find 13 squared is 169, and 1183 will actually break apart as a product of 169 times 7. You know, get your calculator out, start dividing by perfectly squared numbers, and you'll find that 1183 divides by 169 to get 7. If you break those apart, you get square root of 169 times the square root of 7. Square root of 169 is exactly 13, and so you get 13 times the square root of 7. 7 is a prime number. You can't factor that any farther into a product of something with a perfect square. So you get that square root of 1,183 simplifies to 13 times the square root of 7. So the trick here, the key really, is to being able to take the division and see if you can't have that number be a product of something that includes a perfectly square number. And you might have to go outside of your comfort zone of single digits squared. You know, see if it will actually go through and divide by, you know, 15 squared may be something that it divides by. 17 squared. I mean, there's larger prime numbers that have perfect squares that are sometimes used when solving these square roots. So just see if it has a perfect square factor. Don't forget about the larger numbers, and make sure you simplify it completely all the way to the end before you give your final simplified answer.